Have you ever wondered how engineers manage to construct massive structures underwater, defying nature's unforgiving force? Welcome to the enigmatic world of underwater constructions, where human ingenuity meets the mysteries of the deep sea. Consider the Channel Tunnel, an astounding 50-kilometer-long undersea passage connecting England and France, or the Seikon Tunnel in Japan, the longest and deepest operational rail tunnel in the world, piercing through the ocean's depths for over 53 kilometers. These are but two examples of the awe-inspiring structures that engineers have dared to construct beneath the waves. Building underwater is no simple task. It's a battlefield where engineers contend with a host of formidable challenges. They must grapple with the relentless pressure of the water overhead, the unpredictable geology of the seafloor, and the corrosive impact of salt water. And then there are the logistical nightmares. How do you transport materials to a construction site that's underwater? How do you ensure the safety of the workers in such a hostile environment? It's a game of strategy, precision, and innovative thinking. Engineers employ cutting-edge technology and groundbreaking methodologies to overcome these obstacles. They use giant pressurized tubes called caissons, submersible vehicles, and even specially trained divers to carry out their designs. Every step must be meticulously planned and executed. There's no room for error. Yet, despite the Herculean challenges, these underwater marvels stand as testaments to human tenacity and ingenuity. They serve as crucial transportation links, facilitate international trade, and even act as scientific research hubs. They're proof that with enough determination and innovation, we can conquer even the most formidable of nature's domains. Intriguing, isn't it? Now delve into the fascinating process of how these underwater marvels come to life. Every monumental construction begins with a blueprint, and underwater structures are no different. Planning and research are the bedrocks of any successful engineering project. But when it comes to underwater constructions, the stakes are even higher. Engineers need to understand the underwater terrain, soil conditions, and current patterns. These factors can greatly influence the design and construction of the structure. To put it simply, they are the make or break elements of the project. The first step in planning is conducting site surveys. These surveys don't just skim the surface, they delve deep into the underwater world, revealing the fluctuations in the terrain, the composition of the soil, and the direction and strength of currents. It's like peeling back the layers of a mystery bit by bit to reveal the heart of the project. But how do engineers go about conducting these surveys? This is where cutting-edge technologies like sonar mapping and underwater drilling samples come into play. Sonar mapping, also known as bathymetric surveying, uses sound waves to map the underwater terrain. It's like creating a 3D model of the seafloor, one that allows engineers to visualize and plan around the challenges that lie beneath the waves. Drilling samples, on the other hand, give engineers a snapshot of the soil conditions. They involve extracting a small section of the seafloor and examining it for characteristics like density, particle size, and mineral composition. It's this information that helps engineers determine the type of foundation needed for the structure. These advanced technologies are not just tools, they are the eyes and ears of engineers in the underwater world. They provide the vital data needed to ensure the safety and viability of the project. Every step of the planning process is meticulously carried out, every piece of information carefully analyzed. Because in the world of underwater constructions, there is no room for error. Every decision, every move must be calculated with precision. With the blueprint ready, it's time to move to the next stage, the construction. Building underwater is no easy feat, but with the right techniques, engineers turn the impossible into possible. The mysteries and challenges of the deep are conquered not by brute force, but by human ingenuity and a trio of key construction techniques: the caisson method, the cofferdam method, and the immersed tube method. Let's dive into the caisson method first. This technique is akin to building a ship in reverse. Instead of constructing a vessel to float, engineers build a structure to sink. Caissons are watertight structures made on land, then floated to the construction site. There, they're filled with concrete or stone, causing them to sink and form a stable base. It's an intricate ballet of engineering prowess and material science, and it's been used to create everything from bridges to oil platforms. Next up, we have the cofferdam method. This is a temporary enclosure built within or around water bodies to allow the enclosed area to be pumped out. This creates a dry work environment for the major part of the construction. Cofferdams are usually used in construction of bridge piers and other support structures built within water. Finally, the immersed tube method. Imagine taking a tunnel, chopping it into pieces, and then sinking those pieces to the bottom of a body of water. Once these sections, or tubes, are on the seabed, they're connected together to form a continuous tunnel. It's a technique that's been used to connect cities, countries, even continents, and it's as awe-inspiring as it sounds. Each of these techniques has its own strengths and weaknesses, its own set of challenges to overcome. But they all share a common purpose: to tame the unpredictable, unforgiving environment of the underwater world and transform it into something we can use, live in, and marvel at. These techniques lay the foundation of the structure, but the work is far from over. With the groundwork in place, engineers can now start building the actual structure. Now, the construction process can vary greatly depending on the type of structure being built. Let's take underwater tunnels and bridges as examples. Both are marvels of modern engineering, but their construction processes are as different as night and day. Underwater tunnels, for instance, are often constructed using a method known as immersed tube construction. This involves creating massive, watertight sections of the tunnel on dry land. These sections, or tubes, are then floated to the construction site, sunk into a prepared trench on the seabed, and connected together. The tubes are kept watertight throughout the process, ensuring the interior remains dry and safe for the workers. On the other hand, underwater bridges are typically built using a technique known as caisson construction. This involves constructing watertight structures, or caissons, which are then sunk to the seabed. Once in place, these caissons act as a dry, safe space for workers to construct the bridge's pillars. The pillars are built upwards from the caissons, eventually breaking the water's surface and providing a base for the bridge deck. But whether it's a tunnel or a bridge, the use of watertight sections or modules is a common theme in underwater construction. These modules are meticulously designed and built to precise specifications, ensuring they can be seamlessly connected or assembled underwater. This modular approach not only makes the construction process more manageable, but it also allows for a high degree of quality control, as each module can be thoroughly inspected and tested before it's installed. And of course, it's not enough to simply build the structure. It must also be built to last. This means using robust materials and construction techniques that can withstand the harsh underwater conditions. This includes everything from the pressure of the water itself, to the corrosive effects of salt, to the potential for damage from marine life and underwater geological activity. Once the structure is built, it needs to be fortified to withstand the harsh underwater conditions. The underwater world can be harsh, and the structures built need to withstand its relentless pressure. In the realm of underwater constructions, fortification is a crucial element. It's not just about building a structure that can stand, but about creating one that can resist the punishing forces of the underwater world. And this is where waterproofing and pressure management come into play. Imagine being submerged in water, feeling the constant pressure pressing against you. Now, think about a structure, a man-made marvel designed to withstand that pressure every single day. It's quite impressive, isn't it? But how is it done? Well, it all comes down to the materials used and the techniques employed. Waterproofing, for instance, is an essential aspect of fortifying underwater constructions. It's not just about keeping the water out. It's also about preventing the ingress of water that could cause damage over time. This is where materials like reinforced concrete and steel come into play. These materials are not only strong, but also have excellent waterproofing properties. Now let's talk about pressure management. Underwater structures need to be designed to withstand the immense pressure exerted by the water above them. And the deeper the structure, the greater the pressure. So engineers use advanced techniques and design principles to ensure these structures can handle the pressure. But that's not all. The underwater environment is also home to a host of corrosive elements. To protect the structures from these corrosive forces, techniques like cathodic protection are used. This technique involves using a sacrificial metal anode that corrodes in place of the structure, thereby safeguarding it from corrosion. So you see, fortifying an underwater structure is no simple task. It involves a deep understanding of the underwater environment, the right choice of materials, and the use of advanced techniques. It's about creating a structure that not only stands but thrives in the challenging underwater world. With the structure fortified, it's almost ready, but there's one final step. Just like any other construction, underwater structures also require some finishing touches. These final steps are crucial in ensuring that the structure is not only functional, but also safe and habitable for its intended use. Let's take a deep dive into these finishing touches. In the case of underwater tunnels, for instance, installing lighting and ventilation systems is an essential part of the completion process. These are not mere embellishments, but vital components that ensure safety and usability. A well-lit tunnel is necessary for visibility, while a robust ventilation system helps in maintaining air quality and managing the internal environment of the structure. But the work doesn't stop at just installing these systems. There's also the need to add safety features, such as emergency exits. These are critical in case of unexpected situations. Engineers put a great deal of thought and planning into designing these exits, ensuring they are accessible and easy to navigate, even in low visibility conditions. While all of these components are being put into place, there's also the crucial task of waterproofing the structure. This involves using special materials and techniques to ensure that the structure remains dry and secure, even while being surrounded by water. And then, once all these elements are in place, comes the phase of regular maintenance and inspections. These are vital to ensure the longevity and safety of the structure. Regular inspections allow for the early detection of potential issues that could compromise the integrity of the structure. This could include checking for leaks, assessing the functionality of the lighting and ventilation systems, and ensuring the effectiveness of the safety features. Maintenance, on the other hand, involves routine cleaning, repairing any wear and tear, and replacing any components that may have become outdated or ineffective. It's a continuous cycle of evaluation and improvement to ensure the underwater structure remains in top form. And with that, the underwater construction is ready to serve its purpose. The process of underwater construction is truly a marvel of engineering. It is a testament to human ingenuity and the relentless pursuit of progress. A symphony of science, ingenuity, and sheer will. It leaves us in awe of what we, as a species, are capable of achieving. We began our journey by delving into the initial planning stage, the intricate dance of meticulous calculations, risk assessments, and feasibility studies. Every potential hazard was considered, from the crushing pressure of the deep sea to the unpredictable behavior of water currents. It's a game of chess where Mother Nature holds all the pieces, and engineers must predict her every move. Next, we explored the various construction techniques employed in these remarkable projects. From cofferdams that hold back the water to allow dry construction, to immersed tube tunnels that are built section by section and then sunk into place. Each method is a unique solution to the complex puzzle of building beneath the water's surface. We then moved on to the actual construction of the structure. The raw materials are assembled, often in harsh and unforgiving conditions. Each piece must be precisely placed, as even the smallest mistake could result in catastrophic failure. The margin for error is virtually non-existent. Our journey continued with the fortification of the structure. Here, the structure is reinforced to withstand the immense pressures and corrosive effects of the underwater environment. Layers of protection are added, often including a combination of steel, concrete, and protective coatings. Lastly, we discussed the finishing touches. This is where the structure is made ready for its intended use. Whether it's a tunnel, a bridge, or an underwater hotel, the final steps ensure that the structure is safe, functional, and aesthetically pleasing. The marvel of underwater construction is a testament to our ability to overcome challenges and push the boundaries of what is possible. Next time you travel through a tunnel under a river or walk on a bridge over the sea, remember the incredible engineering feats that made it possible.